Chemistry in the AM. I'm your host, Mr. Shindelka, and hot dog, we got an out-of-sight class today. Right now, traffic is flowing smoothly across College Avenue, and I'm just going to give you my weather report here. Currently, it's minus 14. It feels like minus 23 at the wind chill. There's light snow out there and typical winter driving conditions. There's a 30% chance of precipitation this afternoon. We might get up to a high of minus 9. We'll feel like minus 17. Overnight, we got cloudy and snowfall. 30% chance, minus 21 is the low tonight. Okay, now for more with the chemistry. We're going to go through an ice chart example here. Now, I have this on the screen if you're watching live, but recorded. Pause the video. Jot this down. Okay, you've unpaused the video. Now, let's take a look at this together. For this reaction, nitrogen plus hydrogen gives you ammonia. NH3 is ammonia. The initial nitrogen concentration is 0.32. The initial hydrogen concentration is 66 moles per liter. No product, that means 0. The ammonia is 0. At a certain temperature and pressure, the equilibrium concentration of hydrogen is found to be 0.3. So we have an E-line equilibrium concentration. This looks like a job for an ice chart. It's so cool. What's the value of KQ at this temperature and pressure? I say this because you don't have to know what the temperature and pressure is, but these K values and stuff are for a certain set of conditions. Regular air pressure we usually assume, and we usually assume a temperature that's room temperature, about 21 degrees. Reactions happen faster at warmer conditions. That's what changes. And the different pressure, especially with gases, it'll change. We won't get into how it changes things. So, the first thing I want you to do is jot down your given information. Nitrogen is 0.32, so I'm going to put that under here on the. Then the hydrogen is 66. I said there's nothing, no product. Then the other given piece of information is that equilibrium concentration of hydrogen. That's what we have given. The rest we have to figure out. So you can use a calculator on this, just subtraction and addition, but I mean, no shame in that. So what I'm going to do is, I think right now, how to go from 66 to 30, must subtract it, and you can use your calculator if you can't see it, but it's subtracting 0.36. So I'm going to toss that in. Minus 0.36 is the change. This is what's important because the change is proportional to the 1, 3, and 2 used to balance the equation. We've got 3 hydrogens, every 1 nitrogen. It's a 3-to-1 ratio. So if you go down by 36, and when I say 36, I'm talking decimals. I can do this. Down by 36, well, a third of that, 3-to-1 ratio, is 12. If you don't know that, use a calculator, and that's not a problem. So, 3-to-1 ratio for nitrogen, so I'm going to go minus, because it's on the same cell, 0.12. I'm going to do the arithmetic, and I can use a calculator, and yes. The change here, the 12 to 36 ratio, is in a 1 to 3 ratio. The change is always in that, the balanced numbers ratio. Now, you see where we got 36 from? Right. Once you have 36, you know that that is 3 times as much as what you have for nitrogen. So dividing by 3, that's where we get the decimal. So when I drew the 32 minus 12 is decimal point. Okay. We now have an equilibrium concentration for nitrogen. Thank you for that. Now 0, this side there's nothing to go anyways, this, I like taking in 1 if possible. This is a 1-to-2 ratio here. So 12 times 2 is going up. What did I do? I said times 2, and I didn't do it. 24. Thanks. Popped it right away. Yeah. I like this one because it's a 1-to-2 ratio. So I just thought 12 times 2. If you wanted to do it with 36, yeah, that's a 3-to-2 ratio. So there's more involved, and this is why I use a 1. 36 divided by the 3, which is 12, times the 2, you'll get the same number, but it's more steps. I've already divided by the 3 to get this 1. So if you have 1 involved, use that to do all your comparisons. It's just simple. Left side's going down, the right side's going up. 24 plus 0 is my change in this column. So it's 24, 0.24. Have I answered this? No. What's the value of KQ? So now I just put this into the expression. So for this expression here, KQ, NH3 put in my numbers then from the equilibrium concentration. Calculate this. NH3. Decimal 2. I did not do that one right, just saying. No exponent on that decimal 2. That's the answer. H2 has a Q. So decimal third. I do that in my calculator, right? So all around it, 10.66? Yeah, let's call it 11. The K value is 10.66. I'm only using 11 because it's 2 decimals, or 2 significant digits. I don't care if you put 10.66, you get full marks. Okay. Okay, so this is the kind of stuff I want to review before I ask you to do those sheets. I did ask you to do number 1 on the 4 questions. I think I did right. Well, you know, because the answers are given on the right-hand side of the sheet, aren't they? Yeah. So I'm going to pause the video. People working at home, try those sheets I attached yesterday with 4 questions.